Hi, this video is on covalent bonding. In this video, you'll learn how atoms bond together covalently. Covalent bonding has the word valent in it, or valency. And valency in chemistry or valence electrons are the electrons of the outer energy level or shell that could be involved in bonding or are available for bonding. Now, atoms want to become stable, and to be stable they need to have a full outer shell of electrons, and that is where bonding comes in. Now, in ionic bonding, the atoms transfer electrons, so the metal atoms will transfer their electrons to the non-metal atoms to gain full outer energy levels, and you will get positively charged metal ions and negatively charged non-metal ions, and they will then be strongly attracted to each other and form strong ionic bonds. However, in covalent bonding, electrons aren't transferred, they are shared. Now let's take the simplest example, hydrogen. It has atomic number 1 and it's in period 1. It's got symbol H. Now it's got one energy level and it's got one electron in that energy level, and its electronic configuration is 1. Now there'll be other hydrogen atoms with the same electronic configuration. They will only have one electron in their energy level. But to get stability, hydrogen needs to have 2 electrons, because in the first energy level a maximum of 2 electrons can fill the first energy level. So what can happen here? The 2 hydrogen atoms can be strongly attracted to each other and come close together, so much so that is the positively charged nucleus will be attracting the electrons, so much so that their energy levels will begin to overlap. And when that happens, they will start sharing their electrons. So you'll get their electrons will kind of pair up. And so this will be a pair of shared electrons forming a bond. So here we have a bond forming, which is known as a covalent bond. Now we need to check whether each atom feels as if it's got a full outer shell of electrons. Well, the hydrogen atom here, the first one, feels as if it's got 2 electrons in its outer shell, and the second hydrogen atom also feels as if it's got 2 electrons in its outer shell. So both hydrogens are happy. Now, this type of diagram that I have drawn is known as a dot and cross diagram, because the dot and crosses represent the electrons of each atom. Now, there is another way of describing this bonding, and that is known as the displayed formula. So here you draw the symbols for each atom, and then you draw a line between the 2 atoms that are bonding, and this line represents a pair of electrons that are shared between the 2 atoms. Now the molecular formula for hydrogen is H2, and this shows that there are 2 hydrogen atoms bonding together, but this does not give any information on how the bonding happens. Now let's take the example of chlorine. Chlorine has atomic number 17, and it's in period 3 and group 7. It's got symbol Cl, and because it's in group 7, it will have 7 outer shell electrons. So we now put the outer shell electrons 1, 2, 3, 4. Now we start pairing up 5, 6, 7. Now there could also be other chlorine atoms that have the same electronic configuration, and what could happen is that two chlorine atoms could come sufficiently close enough together so that the outer shells or energy levels start overlapping. Now let's add the electrons 1, 2, 3, 4, 5, 6, 7. So you notice a pair of electrons, one from each chlorine atom, are being shared, are paired up. Now let's count each chlorine atom, whether it has a full outer shell. So taking the first chlorine atom here, well, it has 1, 2, 3, 4, 5, 6, 7, 8 electrons, 2 that are being shared. And the other chlorine atom also feels as if it's got 1, 2, 3, 4, 5, 6, 7, 8 electrons. So both chlorine atoms feel as if they've got full outer shells, and so they are stable. Now we have a pair of shared electrons here, and this is known as a single bond, single covalent bond. And we can also draw the displayed formula. So remember, a single line between two atoms represents a pair of electrons that are shared. But if you notice here, this is the dot and cross diagram, and the second diagram I've drawn is the displayed formula. We also have pairs of electrons that aren't involved in bonding. So if you look, there are 3 pairs of electrons on each chlorine atom that aren't involved in bonding. And these are known as lone pairs. And because they're paired up, they are fairly stable and therefore don't want to react, they don't want to bond. So you can add those pairs of electrons onto this displayed formula. So crosses for the first chlorine atom, so there will be 3 pairs of electrons on that atom, and dots for the second chlorine atom, so there will be 3 pairs on that chlorine atom. And when you add the lone pairs, it turns this displayed formula into a Lewis structure. Now, the molecular formula of chlorine is Cl2. So that means there are 2 chlorine atoms bonding together. But this does not give any information about how they are bonding and how many lone pairs there are. For that, you need to draw dot and cross diagrams or a Lewis structure. Now let's take the example of another molecule, oxygen. Oxygen has atomic number 16. It's in period 2 and group 6 in the periodic table. Actually, it's got atomic number 8, not 16. So O is the symbol. Now just drawing the outer shell electrons. So you'll have 6 electrons in its outer shell because it's in group 6. So we start adding the electrons, 4, and now we start pairing up 5, 6. Now the same thing can happen here again. We can have another oxygen atom that is close enough by and will be attracted by the nucleus of the other atom, so much so that the energy levels, outer energy levels, will overlap, and we can add the electrons to this. So 4, and now we pair up 5 and 6. So in this diagram we can see that we've got a pair of electrons that are being shared between the 2 oxygen atoms. Now let's count the electrons in each oxygen atom. So the first oxygen atom here Well, let's count 1, 2, 3, 4, 5, 6, 7. So the first oxygen atom has 7 electrons. And the second oxygen atom, 1, 2, 3, 4, 5, 6. Okay, let's count again. 1, 2, 3, 4, 5, 6, 7. It's got 7 electrons. So both oxygen atoms haven't got full outer energy levels. So they're not very happy and they're not stable. So what could happen is that the two single electrons that aren't paired up on each oxygen atom, they could come together and they can pair up and bond together. So when that happens, we get a new structure which is different to the other one, and the outer energy levels will have to come even closer together. So, and then we have oxygen. Each oxygen atom will have 2 lone pairs of electrons and 2 electrons in the bond, bonding together. So 2 lone pairs and 2 in the bond. So now let's count the oxygen atoms. The first one now feels as if it's got 1, 2, 3, 4, 5, 6, 7, 8 electrons. So it's got a full outer energy level. And the second oxygen atom feels as if it's got 1, 2, 3, 4, 5, 6, 7, 8 electrons as well. So it's going to be stable as well. And that is how the 2 oxygen atoms will bond. So here we have 4 electrons, 2 pairs of electrons being shared. And now let's draw the displayed formula. So here the displayed formula will be slightly different. So you'll have 2 oxygen atoms and you'll have, well, I remember one line represents a pair of electrons being shared. So you have to draw 2 lines to represent 2 pairs of electrons being shared. And this is known as a double bond. We can also add the other electrons. So you'll have 4 electrons on each oxygen atom. And this will turn this structure into a Lewis structure. Now each oxygen atom has 2 lone pairs of electrons. And we can write the molecular formula as well. And the molecular formula for oxygen is O2. The molecular formula for oxygen tells us that there are 2 oxygen atoms bonding together, but it doesn't tell us anything about how they're bonding or whether a double bond is formed or a single bond. For that, you need to draw out the dot and cross diagram or draw a displayed formula.